Now the last situation is that where Rxy equal to 0.75. That is, here also the securities are positively correlated but not perfectly positively correlated. What does it mean? If the rate of return of security X increased by 1%, rate of return of security Y will also increase by 0.75%. So here the two securities are positively correlated but they are not perfectly positively correlated. Now here also, since the correlation coefficient varies from 0 to 1, here we need to test threshold condition. Now as per the threshold condition, as per the threshold condition, we have to test whether Rxy is lower than sigma x divided by sigma y or not. If Rxy is lower than sigma x by sigma y, then we can say the threshold condition is satisfied. But if Rxy not less than sigma x by sigma y, then the threshold condition is not satisfied, and in such a circumstances there will be no diversification benefit by constructing portfolio combining security X and security Y, and in such a case the risk averse investors will invest their money in the security having the lower risk, that means in security X with expected return of 15% and risk of 3%. Now first we need to test the threshold condition. Here Rxy equal to 0.75, that means in the left hand side there is Rxy which is equal to 0.75%. Now in the right hand side there will be sigma x by sigma y, and it is also 3 by 4, that means here also it is 3 by 4. In the question it was given that sigma x is 3% and sigma y is 4%. So lower sigma by higher sigma, that means sigma x by sigma y comes to 0.75. So here both left hand side and right hand side given the same result, that means 0.75. So here threshold condition is not satisfied because left hand side not less than right hand side. So here threshold condition is not satisfied. Since threshold condition is not fulfilled, here there will be no diversification benefit by constructing portfolio consisting of security X and security Y. That means by constructing portfolio, the investors will not be able to minimize the risk of the portfolio. Here the risk averse investors will invest all the money in security X having the lowest risk among the securities, and there will be the expected rate of return by investing in security X is 15%, and risk associated for investing in security X will be equal to 3%. So where Rxy equal to 0.75, there is no need to construct portfolio because there will be no benefit by constructing portfolio regarding minimization of risk. Now there is another alternative process by which we can calculate the weight of security X and security Y in the different scenario, in the different values of Rxy. But this process is to be done by applying a common formula for all Rxy. That means what will be the value of Rxy? The formula will remain same. That means it is a common formula that is to be used for determination of the weight, whatever the situation may be. But this process is not accepted by Calcutta University. So in your examination you should avoid to determination of the weight by applying this method. But in the CA or CMA study mat, in the CA and in CMA, both for the both courses, in the final courses, you find there is a paper of strategic financial management, and in this paper portfolio management is a important chapter, and if you read this study mat carefully, you will find this formula in this study mat, in the study mat of CA and CMA. For both courses, the study mat issued by Institute of Chartered Accounts or Institute of Cost Accounts, you may find the formula, that common formula. So in their examination, the CA and CMA student, they are using this common formula for minimization of time. But in your final MCOM examination, you should try to avoid to use these tactics, but you may apply this formula for verifying your answer. Now, what is the formula? Here the formula, the common formula for determination of weight of security X, that means this formula is to be used for all types of RXY. Here the weight of security X is to be measured by applying formula sigma y square minus cov xy divided by sigma x square plus sigma y square minus 2 cov xy. Now, the proportion of investment in security Y, that means Wi, is equal to 1 minus Wx. First, we have to determine weight of security X by applying this formula, and this formula is common. That means this formula is to be used in respect of all the values, in respect of all the situations. So, this will be taken as the common formula. Now, after determination the weight of security X, we can easily find the weight of security Y by applying the formula 1 minus Wx. Now, here cov xy is to be calculated first. Now, we know that correlation coefficient Rxy is equal to cov xy divided by sigma x into sigma y. So, cov xy, by rearranging this, we have cov xy equal to Rxy into sigma x into sigma y. So, in place of cov xy, here we can write Rxy into sigma x into sigma y. Now, here we have a chart by which we can determine the weight in respect of different situation of RXY, and in respect of that RXY we can determine the risk associated with portfolio supporting the weight that we have calculated by applying this formula. Now, for Rxy equal to minus 1, here we have to use the common formula for determination of weight of security X, that is sigma y square minus Rxy into sigma x into sigma y, that means it is the cov xy. In the denominator we have sigma x square plus sigma y square minus 2 into Rx into sigma x into sigma y. Now, here these values are being given in the question. Here sigma y square is 16, Rxy equal to minus 1, Rxy equal to minus 1, sigma x and sigma y are 3 and 4, and in denominator we have sigma x square equal to 9 plus sigma y square equal to 16 minus 2 into Rxy into sigma x into sigma y. Now, by putting this value, we have Wx equal to 28 by 49, that means 4 by 7, and Wy equal to 1 minus Wx, that means 1 minus 4 by 7, that is 3 by 7. Now, by taking weight of Wx and Wy, this is the optimum weight where Rxy equal to minus 1. Now, by putting this value in the variance function, in the standard deviation function, we can easily calculate the risk of the portfolio, and here the risk of the portfolio becomes 0. We know that where Rxy is minus 1, that means securities are perfectly negatively correlated. In that case, if the weight is determined properly, then the risk of the portfolio will become 0. Now, where Rxy equal to minus 0.5, then also we can determine the weight of security X by applying this common formula. That means Wx equal to sigma y square minus Rxy into sigma x into sigma y divided by sigma x square plus sigma y square minus 2 into Rxy into sigma x into sigma y. By putting the value, we have Wx equal to 22 by 37 and Wy equal to 1 minus Wx, that is 15 by 37. By putting the weight of security X and security Y in the standard deviation function, we can calculate the risk of the portfolio in this case, and here risk of the portfolio comes to 1.71%. So this is the optimum weight where RXY equal to minus 0.5, and this is the risk associated with portfolio in this case. Now where RXY equal to 0, then also we have to calculate the weight of security X and security Y by applying the same formula. This is the common formula. So for all the value of RXY we have to use this formula, and here also by putting the value of RXY, sigma X and sigma Y, the weight of security X comes to 16 by 25, weight of security Y comes to 9 by 25, and by putting this weight in the standard deviation function, here the risk of the portfolio comes to 2.4%. So where RXY equal to 0, that means security are independent of each other, then the optimum weight of security X and security Y will be 16 by 25 and 9 by 25, and in that weight the risk of the portfolio will be 2.4%. Now where RXY equal to 0.5, then also we have to calculate the weight of security X by applying this common formula, and here the weight of security X comes to 10 by 13, weight of security X comes to 3 by 13, 1 minus WX, that means 3 by 13. This is the optimum weight where RXY equal to 0.5, and by putting this weight we can calculate the risk of the portfolio, which comes to 2.88%. Now where RXY equal to 0.75, threshold condition is not to be satisfied, so there is no need for construction of any portfolio, and where RXY equal to plus 1, that means where securities are perfectly positively correlated, there also we does not need to construct any portfolio. So in respect of RXY equal to 1 and in respect of RXY equal to 0.75, there will be we does not need to construct portfolio. So there is no need to calculation of weight of security X, weight of security Y, portfolio risk, etc. Now if we watch carefully at this chart, we find that we know that RXY varies from minus 1 to plus 1. If we start from minus 1 and gradually proceeds to plus 1, then we find that the risk is minimum where RXY equal to minus 1, because here where RXY equal to minus 1, risk of the portfolio is 0. Where RXY equal to minus 0.5, that means we gradually proceeds to RXY equal to 1. When RXY equal to minus 0.5, here the risk comes to 1.71%. So the risk will get increases. Now where RXY equal to 0, then the risk comes to 2.4%, that means risk is increases. Now where RXY equal to 0.5, portfolio risk comes to 2.88%, that means there is gradually increase in the risk of the portfolio with increase in the value of RXY towards minus 1 to plus 1. Now but in respect of RXY equal to up to the value of RXY equal to 0.5, we have the diversification benefit, because in all this case the risk of the portfolio is lower than the risk of the lowest risky security contained in the portfolio. So there is diversification benefit in respect of all these values of RXY. But where the RXY reach to 0.75 or RXY is equal to 1, then there will be no, there will be we does not need to construct any portfolio, because if we construct portfolio in this case, then we cannot gain any diversification benefit. That means we are not able to reduce the portfolio risk below the risk of the lowest risky security contained in the portfolio. So here we can determine the weight of security X and security Y by applying this common formula, but for the examination purpose you should try to avoid to calculate the weight by applying this formula, because this is not supported by your university, though you may use this formula for verifying your answer.